Welcome. Today we will solve Leetcode 2337, move pieces to obtain a string. For this problem, we're provided two strings, start and target. Both strings are of the same length, and each string consists only of three characters, L, R, and the underscore. They call the underscore a blank, so we'll do that too. The rules for transforming or moving a character are as follows. The L character can only move to the left when there's an underscore or blank to the left. And R can only move right if and only if there is an underscore to the right of it. Okay, so let's go over a couple of these in this example. So in this example, this start here, L can move to the left without any problem because there's a blank to the left of it. So that would look like target so far. And all of these R characters can move to the right because there are only underscores in front of them. So no problem. We can adjust this start string to look like this target. Moving on. Let's look at this example. R can move to the right, so R can move here. However, notice that it will not be able to pass over all the way to the right because it is blocked by this L. And same thing for the L, it can't pass over to the left side of R. So this example returns false. And I think the most important example is probably this one, because looking at it, it would seem maybe initially that it could be true. However, R can only move to the right. So the start value has a right at the last index. In order for this start to be transformed to this target, the R character would have to move to the left, and that isn't allowed. Remember, R can only move to the right, L can only move to the left. L can only move to the left if there's an empty space there, or blank underscore. Okay, so that's enough for us to get started. So let's go over an algorithm that we'll use. So we'll use a two-pointer approach. So I've created an example for us here. So S will be the starting string index, and T will be the target index we'll be focused on. And for ease or convenience, we'll let N be the length of the string. We'll just call it 2 for now. It's the length of each of those strings. So what we'll do is we'll loop while S is less than N or T is less than N. Okay. First thing we'll do is, when we're looking at each of these strings, is we'll examine each of them, and we'll ignore the blank spaces until we encounter a character. So let's look at this one here. So here we'll loop start until we encounter not the blank space. So it'll be something like, we'll do S plus equals 1. And we'll do the same thing for the target. So loop target until we encounter not underscore or blank space. Now, why are we doing this? We're doing this because, remember, the underscores don't really mean too much. They're just there. We're really focused upon the characters. The L or R are the characters that define if the problem will be solvable. or will they define how the movements of the characters are allowed or not. Okay, so let's continue. So once we travel as far as we can until we cannot, we'll ask ourselves 3 questions. The first question is, well, sorry, before I do that, it is possible that one of these has already traveled to the end. So what I mean by that is this. What if one string looks like this and the other looks like that? So we want to check, let's maybe move this up so we can see it. We want to check, so if s equals n or t equals n, so that means one of them has already looped to the end. We'll want to check, we'll return, they should both be equal. So return s equals t. So if one of them looped through the end, all the way to the end, that would mean either one string looks like this and the other didn't. But in order for them to be true, they would need to both be equal. So I'm going to add this check here. Next, we'll ask ourselves 3 questions. Question 1. Question 1 is, do the characters match? So that means, does start at s equals target at t? So we would at the very least need that. It should make sense that we want the characters to match. The very first non-underscore character, they need to match. Otherwise, return false. This is because they can't be made. The start cannot be converted to the target. Next question. Now this is the tricky part. If start s is an L and the start index is less than t, return false. Now what do I mean by that? So let's go over this example here. So in this case, considering this string, s would be 0 because this is the first character that's not underscore, so this would be 0. Target would be 1. Here, remember here, we're looping until there are no more underscores. So what do we have here? That means that in order for us to get this start to look like target, well, we can't do it. Because remember, L cannot move. We can't move L to the right. We can't move this. We can't switch these. Remember, L can only move to the left. And so in this case, we can never move this L beyond any farther to the right than where it is currently located. So we can't move L over here. So that, again, so we're checking if this S is less than T. So remember, that's the case right now. S is less than T. We can't move it. We can't move S to the right. The best we can do is if they're equal, that's fine. But we can't move it. So that's why we return false. And that's very important that I go over that. And same thing for R, but a little bit of a reverse or inverted logic. So if start of S is R and S is greater than T, then return false for the same exact reason. So let me show you what I mean by that. So suppose we had this here. This was here and we're here. So start. Okay, so in this example, start, if we're looping this, performing this loop here, remember we loop until we find a non-underscore. So that means S would be 1. So in that case, we would be here, right? And for this example, for target, we'd be here. So S would be at 1, target would be at 0, the target index. And so notice though how if we are at an R and S is bigger than T, well, what does that mean? Remember, if we want this start to look like this target, the best we can do is move this R character farther to the right. But remember, they want this R to be moved to the left, and that's not allowed. So that's what we're checking here for this here. Return false. Okay, so these are all the bad checks. These are let me see. Bad checks. And if we see any of these, we can just return false. Otherwise, things are okay, so we can just continue on. So we can progress the starting index and target index. So S plus equals 1 and T plus equals 1. Okay? And if we've finished this loop and there aren't any issues, then we can just return true. And that's the algorithm we'll be using to solve this problem. So again, I want to go over these points again. It should make sense for this first question or check is that the character should match at that index. Secondly, if we are at L and S is less than T, that means we had something like this here, just as a reminder. Well, remember, if we want to move this, we cannot move this L to the right as they want. So we're checking, in this case, this was what, 0, and this was T. So we cannot have, if S is less than T, that's going to be a problem. So that's why we have this here. And then for the same thing for the right, but inverted. Let me just write that out real quick, just as a reminder. Let me just say this. That would be here, and then for this one we have this. So in this case, S is 1, T is 0. So if the character at the S index is an R, and S is greater than T, so 1 is greater than 0, return false. Again, we have this R here, and the best we can do is move it to the right. But they want this R to be at this target, which is behind it, but we're not allowed to move the R character to the left. So again, that would be a false, or that would be, yeah, that would make this not possible. Okay, so I think that's enough for us to get started. So let's do it. So the first thing is we'll get the length of the string, and it doesn't matter which one. So n equals length of s. And then we'll set the pointers. So this little s will be the pointer for s, and t will be the pointer for the target. Okay. And we'll perform this while either of these is less than n. So I use an OR here, and I'll point out why it's okay for it to be an OR. Now we'll skip blanks in S, because remember, we're only concerned with we want to compare the non-blanks, the non-underscores. So we'll do that. So while S is less than n and S of S equals an underscore, we'll call S plus equals 1. Same thing for the blanks in the target. So skip blanks in T. So while T is less than n and T of T equals underscore. Okay, and now remember, we need to check, supposedly if one of them goes all the way to the end, that would mean both of them would have had to reached the end. But if not, we have a problem. So if one of them is at the end, so if S equals n or T equals n, we need to check if that means one of them is already done. So we need to check if they should be equal. And so with this check here, that allows us to use an OR here. Okay, I just want to make that point. moving on. Now we ask ourselves these three questions. And if one of these isn't true, we return false. So if s of s not equal to t of t, so this character at the s index for start and the character at the t index for target, if they're not equal, we'll return false. Or we'll just put this here. Yeah, I want to make sure our preference order isn't compromised. So let's make sure we're right. We'll do that. Or what? Remember, if the character at s equals an L and s is less than t, then we have a problem. Or if the character at s is an R, but it's beyond t, we won't be able to move the R in the right direction. So if that's the case, we return false. Let's see if I set this up correctly. Should be okay. We need an or here. I think that's fine. Or I think we can add one more parenthesis here. Okay. Otherwise, we can continue on. So s plus equals 1, t plus equals 1. And if we've exited the loop, that means we haven't returned so far, so we can return true. And that should be good to go. Let's check it locally. I will show you my initial thinking, and I'll show you why it didn't work. I had this maybe a crazy idea initially. So my original idea was, I thought to myself, couldn't we just do this? So let me just comment all this out. So my initial idea was to do it in one line. And let me show you how. I thought to myself, couldn't I just use replace all the underscores with nothing, and compare that with t and replace all of those underscores with nothing and return that and see if that works. So if I do this, so I'm checking it locally and it fails, because the reason why it fails is because, remember, R cannot move to the left, and that's what they wanted for the target. So that was my initial idea. And I think it's okay to try or come up with different approaches, and if it doesn't work, then that's okay. So I hope this wasn't, or this was somewhat tricky, and I hope we learned something today. If you have any questions or comments, let me know, and I'll try to answer them. Other than that, have a great day. Take care.